histograms. And their histograms is for categorical, quantitative data, quantitative data. Okay, and when we do histograms, there's two ways to do it. There's exact value, and we have something called intervals. And sometimes we call them case intervals or something like that, that we say, oh, it's not exactly 5, it's not exactly 6, it's in between 5 and 6. Okay, and bars are touching. And we can use frequency or relative frequency. Now, if you remember, frequency is counts, relative frequency is percents. Okay, so let's take a look at an exact value histogram. I am looking at Roman numeral number 4, letter C, number 1. And we have number of goals in 34 soccer games, and they have 30278. Two, 4, 3, 5. Dot dot dot. All the way up to 115. These are all individual data. Okay, now notice we have no decimal values. We have a small range of data. So we could use a dot plot, but I'm going to show you an exact value, which kind of gives you the same look, okay? And what we're going to do is we're going to count up how many zeros do I have, how many ones, how many twos, how many threes, how many fours, 5, all the way up to my biggest number. And my biggest number is 8. Okay, so I count up all my zeros, and I have 1 of those. Count up all my ones, I have 8 of those. 6 twos, 7 threes. So this is goals here, and this is how much frequency. 4 fours, 3 fives, 3 sixes, 1 7, 1 8. Okay, so there we go. Put it here. I'm actually going to go a little bit to the left here, and I'll show you why in a moment. 0, 1, 2, 3, 4, 5, 6, 7, 8. This is goals. Over here is frequency. We give it a title. Soccer goals. And our highest frequency is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm actually going to go all the way over here. Now, when we do this, we're going to put the bar around the number on exact value histogram. So we're going to put it around 1, around 2, around 3, and around 0. That's why I went over here a little bit. So I have 1, 0. So it looks like this. 8 ones. Oh. Six twos. So here's 2, it's around 6, around 2. Seven threes. Four fours. Three fives. Three sixes. One seven. And 1 8. So I got a title, labeled my axes, and here's my graph. Now if I had to describe my graph, again, this is quantitative data, so I would use GSOCs. Gaps, none. Shape, kind of draw a little thing around here like this. It's being spread out more on the right hand side, longer tail on the right hand side, so it's skewed right. Outliers, don't know yet, and center and spread, don't know yet. So how can I know? Now, what you can do is put this into list 1, number of goals, and put this into list 2. So when you, okay, so stat, edit, okay, so stat, edit. In the list 1, I'm going to put 0, 1, 2, 3, all the way to 8. And in list 2, I'm going to put the frequency. 1, 8, 6, 7, 4, 3, 3, 1, 1. Now you're going to hit stat, calculate, one var stat. Now remember before I had you get in the habit of hitting second 1, so you're going to hit second 1 and then the comma button, and then you're going to hit the second button and 2. And then we get the mean is 3.1, 3.08. The standard deviation, 1.99. Now notice this is skewed right, so I probably shouldn't use mean and standard deviation. Again, I'm going to come back to outliers here in a moment. So what should I use? Well, for skewed data, I should use median. The median is at, now hit the down arrow, 3. 3 what? Goals. IQR. Spread, excuse me. But we're going to use IQR. The middle, 50% IQR is, well, defined IQR, I have to know Q1 and Q3. Q1 is 1, Q3 is 4. So it is 4 minus 1, 3. So it's 3 goals. Now I have to determine if there are any outliers. Okay, let me clean this up a little bit here. Okay, so you're going to hit second, y equals, enter. And you're going to go to your fourth choice, which is the modified box plot. Okay, and it says X list. X list, you're going to hit list 1. Frequency, you're going to hit second 2 for list 2. And then zoom 9. And it shows a right skew. And if you hit trace, it tells you all your min, Q1, Q3, so on and so forth, but it also shows you there are no outliers. Okay, so that's an exact value histogram. Now let's look at an interval histogram. Most common. This is what we use most often, because most often things don't just happen nice and perfect for us. So again, we're looking at Roman numeral number 4, part C. Now we're looking at number 2. Okay. And it says range, which also means we're going to use something called case intervals. And they have gas mileage again. And we have 50 pieces of data, miles per gallon. We start off at 36.3, 32.7, 40.5, and all the way up to 36.7, 34.8, and 38.1. Okay. Now, notice we have all these decimals. I mean, we could round it and maybe do an exact value histogram, but it's probably better that we use a range. Okay. So we want to look at the smallest. The smallest is 31.8. And then we're going to look at the largest, which is 42.1. So I want to make about, I don't know, 5 to 10 case intervals. Okay, I want to make 5 to 10 of them. And let's see, I'm between 31 and 42, about 32 to 42. So I can go by ones. If I go by ones, I'll get me at kind of my max here. If I go by twos, it kind of gets me at my minimum. So I'm going to go by, I'm going to try to go in the middle here. I'm going to go by 1.5. Okay. So I'm not starting off at 0. So I'm going to put a break in the graph. That's what this is here. And I'm going to start off at 31.5. A little bit lower than 31.8. It'll make it easier to add 1.5. So I'm going to add 1.5, make it 33, 34.5, 36, 37.5, 39, 40.5. Oh, kind of running out of room here. Try to go this way. 40.5, 42, excuse me, 42. And then 43.5. Okay. So what I'm going to do here is count up how many are between 31.5 and 33. But now we have a problem, because between 31.5 and 33, but now if you look at, so okay, what about 33? Where does that go? Does it go here? Or does it go here? Which case interval does it go? The first one or the second one? That's what we got to determine. It can't go in both. Can't count it twice. Okay? Can't count it twice. So this is what we do. I make a little star down here, and I write include, and I do this for all interval histograms, left endpoint, not right. Now what does that mean? So let's look at 33 again. Include left endpoint but not right. So 31.5 is here, 33 is here. In this interval, I include 31.5, but I do not include 33. Okay? So include left endpoint but not right, it would not go into that case interval there. What about here? Now if you look here, include left endpoint is now 33 here, but not right. Your right endpoint here is 34.5. Okay, so 33 would be going into the second case interval, not the first. Okay, some people have a little bit of trouble with that at first. Include left endpoint but not right. All right, so you're going to count up how many are between 31.5 and 33, including 31.5, but not including 33. And we have 4 of those. So I just write 4 here. Okay. Now I'm going to say how many are between 33 and 34.5, including 33, but not including 34.5. Okay. So that makes a difference here, because I think we have some 34.5s. So we have 3 of them. How many between 34.5, including 34.5 now, and 36, but not including 36? And we have 6 of them. Between 36, including 36, and 37.5, but not including 37.5, 17. Between 37.5, including, and 39, not including, 7. Between 39, including, 40.5, not including, 8. And then we'll have 5 here and 1 here. On this side, we're either going to put frequency or relative frequency. Well, we got frequency already. Let's just keep it that way. When would we do relative frequency? We do relative frequency probably when we are relating 2 or more graphs. And we got to go all the way up to 17, so maybe not by 1s, maybe by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. Let's give it a title. Gas mileage. And label your x-axis, miles per gallon. Now the bars are touching. This is quantitative data. Categorical data is when the bars do not touch. Those are those bar graphs. That's not this here. Sometimes I put those numbers above there just to remind me how many I have. You don't have to. That's just a personal preference. Drawing straight apparently is not a forte. So 7. Oop, oop. There we go, 7. 8, 5, and 1. Now we are going to describe. It is quantitative data, so we use GSOCs. Gaps. I don't see any gaps here. None. I'm going to use it right now. Shape. That looks pretty symmetrical. Outliers. Don't know yet. Center. Spread. So we're going to put all this data into list 1. Then you're going to hit Stat, Edit, 1var stat, second 1 for list 1. Okay, and when you do that, I get mean is 37.3, standard deviation 2.4, your 5-number summary, your min 31.8, Q1 36, median or Q2 37, Q3 39, and max 42.1. So now, since this is approximately symmetrical, I can use mean. The mean is at 37.3 miles per gallon. And if we use mean, we should use standard deviation. So now we have to determine, are there any outliers? So, second, y equals, go to your modified box plot, and your X list is second 1 or list 1, and your frequency, you may have to hit the alpha key to change it back to frequency of 1. Okay? Don't know if you need to hit the alpha key or not. But if you use this in order what I'm doing this right here, then we used list 2 in the frequency, but now we're going back to frequency of 1. So if you do that and then hit zoom 9, you'll find out there are no outliers. Okay, so hopefully you understand a little bit about the two different types of histograms. Good luck. You have just looked at histograms, and in histograms we have two types. We have exact value and the case intervals. Please make sure on the case intervals that you include left endpoint but not the right, and remember that this is used for quantitative data. Good luck on your histograms.